This lesson, we are going to learn how to determine the horizontal asymptote and the oblique asymptote. Horizontal asymptotes occur when the numerator of a rational function has degree less than or equal to the degree of the denominator. Oblique asymptotes occur when the degree of the denominator of a rational function is 1 less than degree of the numerator. Case 1. When the degree of the numerator is less than degree of the denominator, we know we will have a horizontal asymptote at y equals 0, and we will not have any oblique asymptote. Example 1. Let's look at the function f(x). We know degree of the numerator is 1 and degree of the denominator is 2. Therefore, we say the horizontal asymptote is at y equals 0, and we do not have any oblique asymptote. Now, let's check the end behavior of the function along the horizontal asymptote. In order to check the behavior on the right end, we have to let x approach positive infinity. Here, we're going to use x equals 1,000 to substitute into the function to find the y value, and we will get y equals 0.001, which is almost 0, but a little bit higher than 0. So we can write as x is approaching to positive infinity, y is approaching to 0 from above. Next, we have to check the left end of the function. That means we have to let x approach negative infinity. Here, we're going to use x equals negative 1,000 to substitute into the function to find the y value, and we will get y equals negative 0.001, which means it's almost 0, but below 0. Therefore, we write as x is approaching to negative infinity, y is approaching to 0 from below. So please note that the positive sign means above and the negative sign means below. Let's take a look at the graph. We can clearly see there's a horizontal asymptote at y equals 0. And on the right-hand side of this function, the function is approaching to the horizontal asymptote from above. And on the left end, the function is approaching to the horizontal asymptote from below. Case 2. When the degree of the numerator equals to the degree of the denominator, the horizontal asymptote can be found by dividing by the coefficient of the highest degree term in the numerator by the coefficient of the highest degree term in the denominator. And once again, we will not have any oblique asymptote. Let's look at an example. In the numerator, the highest degree term is 6x squared. So the coefficient of the highest degree term is 6. In the denominator, the highest degree term is 3x squared. So the coefficient of the highest degree term is 3. Then we can find the horizontal asymptote by dividing those numbers. So y equals 6 divided by 3. That means y equals 2 is our horizontal asymptote. And we do not have any oblique asymptote. Let's check the end behaviors. On the right end, x is approaching to positive infinity. Once again, we use 1,000 as the x value, substituting into the function to find the y value. As you can see, this y value is very, very close to 2, but a little bit higher than 2. So we say y is approaching to 2 from above with a positive sign. On the left end, x is approaching to negative infinity. We use negative 1,000 as the x value, substituting into the function to find the y value. Once again, you can see a y value that is extremely close to 2, but a little bit higher than 2. So we say y is also approaching to 2 from above with a positive sign. Let's look at the graph. There is a horizontal asymptote at y equals 2. On both ends of the function approaches the horizontal asymptote from above. Case 3. Degree of the numerator is higher than degree of the denominator. Then we will not have any horizontal asymptote. However, we will have an oblique asymptote. Oblique asymptote is the quotient resulted from the long division. Let's look at an example. Degree of the numerator is 2, and degree of the denominator is 1. So we know degree of the numerator is higher than degree of the denominator. Therefore, we do not have any horizontal asymptote. So that's long divide to find our oblique asymptote. Then we know the oblique asymptote will be at y equals 6x minus 4. Now, let's check the end behavior. Once again, on the right end, we have to let x approach to positive infinity. Here, we're going to let x equals 100 to find the y value, which is at 596.0099. So we know as x is approaching to positive infinity, y is also approaching to positive infinity. However, we would like to know whether or not the function is above or below the oblique asymptote, so we have to find the y value of the oblique asymptote when x equals 100. As you can see, the y value on the function is higher than the y value of the oblique asymptote. Therefore, we say y is approaching to positive infinity, which is also above the oblique asymptote. On the left end, we have to let x approach to negative infinity. Here, we're going to use negative 100 to substitute into the function h to find the y value, which is approximately negative 604.01. Once again, we have to know whether or not this y value is higher or lower than our oblique asymptote. So we're going to find the y value of the oblique asymptote when x equals to negative 100. As you can see, the function has a lower y value than the oblique asymptote. Therefore, we say y is approaching to oblique asymptote from below. Let's look at the graph. There is an oblique asymptote at y equals 6x minus 4. On the right-hand side of the graph, the function is above the oblique asymptote, and on the left end of the function is below the oblique asymptote. Please remember, a rational function can go through either a horizontal or an oblique asymptote. However, a rational function can never go through the vertical asymptote.